Bismillahirrahmanirrahim. Let's continue inshallah with our exploration of the circumcenter, which is the point of concurrency of the perpendicular bisectors. Now we had drawn this particular triangle here, and this is an acute triangle, and I had drawn here for you the perpendicular bisectors. So these are the perpendicular bisectors. And we had suggested that the point of concurrency, and I labeled it over here P, and that point of concurrency is called the circumcenter, because it is the circle that circumscribes this triangle. So this is the circle here. It circumscribes the triangle, and the triangle itself is said to be inscribed or inside the circle. And I mentioned also that this segment here from P to C over here, and we had labeled it R, and that radius is given a name itself, and that radius is called the circumradius, and that's easy enough to remember. So again, the key thing is that perpendicular bisectors are concurrent, and the point of concurrency is called the circumcenter. Now, we had taken an example of an acute triangle last time. So what would happen if you tried to draw the circumcenter of an obtuse triangle and a right triangle as I've drawn over here? So let's try to do that. Let's see what would happen if I were to draw, let's say from here, the perpendicular bisectors. I'm just kind of like eyeballing this, okay? So hopefully I'll get this semi-right. So there's the perpendicular bisector here, I think, of this side over here. And, right. And then I'm going to draw the perpendicular bisector from here, okay? And that's kind of like this, I think. Okay, and finally of the third side, okay, eyeballing this. If I were to draw this out, you would have, well, they actually meet over there, outside the triangle. Okay, so I have drawn the perpendicular bisectors here of an obtuse triangle, and I observed that they are concurrent, okay, and the circumcenter on the other hand, is on the outside of the triangle, whereas for an acute triangle, the circumcenter was on the inside of the triangle. For an obtuse triangle, the circumcenter was on the outside. Okay, let's clean this up. Okay, fine. Let's see what happens if I do the same thing for a right triangle over here. Okay, so I happen to have a right triangle handy, so let's do this over here. I'm going to try, I'm just again, I'm eyeballing this, so here we go. Okay, that's the, over here, and eyeball this here, okay, oh, like this. And it so happens that the circumcenter of a right triangle is on the hypotenuse right here, this right here. And this side is going to be kind of going to this side. And you don't really have to draw a right triangle over there because, you know, it's on the line like this, okay? So what we observe is that the circumcenter of the right triangle is on the hypotenuse, okay? And the circle is kind of going to look like something like this. This is an artistic representation. Right, yeah, it's impressionist circle. And over here, the circle, this is the radius, and that this circle is going to look like that. Okay, the radius is over there. So now we have examples of how the circumcenter is actually is not inside the triangle. For an obtuse triangle, it's outside. For a right triangle, it is on the hypotenuse. And for an acute triangle, it's actually inside the triangle. So this is an interesting little characteristic of the circumcenter. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.